is a force that is applied through a string, a rope, or a cable, or something like that, and it will pull on an object. It is always a pull, which might be obvious, and you can't, if you've got a rope, you can't push something with that rope, because the rope will go slack, and you won't have anything going on there. So you're always pulling, and the tension in the rope, or string, or cable, or whatever, is the same as the force applied to objects at both ends. Okay. This creates a few kind of weird sorts of scenarios. Anyway, but the tension in the rope is the force applied to objects at both ends of the rope. Okay. So if two people are holding a rope, and the tension in the rope, which we usually abbreviate with capital T, is 10 newtons, then this person has a force of 10 newtons being exerted on them that way. This person has a force of 10 newtons being exerted on them that way. Okay. In many scenarios, it doesn't actually matter that a force is a tension. It's just another force that shows up in Newton's laws. But there are a few things about ropes that are interesting. The reason that we talk about tension specifically is because it is often used to redirect forces. Ropes or cables or whatever are often used to redirect forces by running the rope over a pulley. For example, if you have a well, like way back in the day, if you had a well and a bucket on the well, so a bucket going down the well, someone would pull, not quite vertically on this rope, but this pulley would then, redirect that force to be able to pull the bucket up or down the well. Anyway, so that's why one reason why tension is somewhat important is how it redirects forces like that. Tension can also happen on parts of a rope. Okay, so imagine say you've got two walls, right? And we've got a rope hanging between these two walls, and there's something hanging in the middle. Say, I don't know, a shirt or something. Okay, there's my beautiful shirt. It's being hung from this line to dry. You can treat these two pieces of the rope, the left and right halves, as though they are two separate ropes. Okay, and so there's a tension going this way, there's a tension force going this way, tension force going this way, and then this tension is what's supplying the upward force for the shirt to hang there without falling. Right? So there's an x and a y component to these two tension forces. The x components cancel out. The y components are both upward, and so they pull the shirt upward. Let's say, for example, we have a chandelier. Weight 220 newtons, held up by 4 cables, each of which is angled at 53 degrees above the horizontal. Find the tension in each cable. I wanted to throw this in here because remember, weight is a force. So if you're given a weight of 220 newtons, you don't have to multiply by 9.8. 220 newtons is the gravitational force acting on the chandelier. It is the weight. So we've got our chandelier, okay, which wouldn't look like a box, but whatever. And we've got 4 cables, and one would imagine that one would be going to the left, one would be going to the right, one would be angled forward, one would be angled backward. It's kind of hard to draw. But regardless, they're angled at 53 degrees above the horizontal. So we've got a tension in each cable. In the y direction, our chandelier is hanging, and so what forces do we have acting? We have gravitational force, and then we have these 4 tensions. So we have tension, and a component of that tension is going upward, and there are 4 of them. So that's the upward force, and the downward force is just the gravitational force acting on the object. So the tension in each rope we can find by plugging in these numbers. And if we stick that into our calculator, 220 over 4 sine 53, we get the tension in each rope of 68.867, etc. newtons. It's one example of a kind of problem that might show up because of tension. Let's take another example. Let's say upward at 1.8 meters per second squared. Mass of the elevator and the people inside is 735 kilograms. The elevator is pulled upward by a single cable. What is the tension in the cable? Draw a picture. Our elevator, or maybe people inside. Doesn't really matter. We got this cable exerting an upward tension force, and we've got gravity exerting a downward force. So we know the sum of the forces in the y direction is equal to mass times acceleration, and that is equal to we got a tension going up, and we got an mg going down. So our tension is equal to ma plus mg. It's going to be 735 times 1.8 plus 9.8. So our tension will come out to be times 1.8 plus 9.8. Our tension comes out to 85.62. Sorry, 85.26 newtons. That's another problem that you might, another sort of problem that you might see.